بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is chapter 1, linear equations and functions, and we will start by section 1.1, solutions of linear equations and inequalities in one variable. Let us start by defining an equation. An equation is a statement that uh, when two quantities or algebraic expressions are equal. So you have the equal sign and two quantities are there. For example, this is an equation, the equal sign, and 3x minus 2 is 7. This is an equation in one variable because you have only one variable, which is x. Now, the value of the variable that makes the equation true is called a solution of the equation. So for example, if you replace x by 3, you will get 9 minus 2, 7 equals to 7. So 3 is a solution of this equation. While if you replace x by 0, you get negative 2 equals to 7. This is not true. So 0 is not a solution. So the only solution of this equation is 3. Finding the solutions of the equation is a method called solving the equation. So when we solve the equation, we find the solutions of the equation. The set of all possible solutions of the equation is called solution set. So solution set is the set of all possible solutions, and usually we denote it by SS. So SS equals, and you write the all possible solutions of the equation. There are equations that are always true. They are true for all the values of the variables in the domain, okay? All the values in the domain of their variables. Uh, such equations are called identities. So for example, this is an identity because 2x minus 2 equals 2x minus 2. This equation is always true. If you replace x by any number, it would be true. So it is an identity. There are equations that true only for certain values, for one value or two values or three values, only certain values. Such equations are called conditional equations, or we will simply call them equations. Two equations are equivalent if they have exactly the same solution set. So if they have exactly the same solution set, we call them equivalent. Now, how to solve an equation? We usually use these three properties. Substitution property means if you have an equation like this, you can simplify the left-hand side and write it again here. So this is called substitution property. So if you simplify this, 3x minus 9, expanding, negative half times 4 is negative 2x, negative half times negative 18 is positive 9 equals 4. So here we used substitution property. Again, you can add here, add like terms. So 3x minus 2x is x, and 9 cancels with negative 9, so x is 4. So writing x instead of the left-hand side here is called substitution property. So the solution of this equation is 4. Addition property, sometimes we need to add a number to both sides. We can do that. We can add or subtract a number, same number, from both sides. We do that when we have something like this, x minus 4 equals to 6. We usually need the variable to be alone in the left-hand side. So I don't need negative 4 here. So what should I do? I add 4 to both sides. When you add 4 to both sides, negative 4 plus 4 would be 0, and you will have x only. And in the other side, you will have 10. So the solution of this equation is 10. While if you have an equation like this, I have x plus 5, and this time I want to get rid of the positive 5. So I need to subtract negative 5. We can do that. We can subtract -5 or add -5 to both sides. Subtract 5 or add -5 to both sides. So I will get 5 will be cancelled with -5, and I will get x equals 12 minus 5, which is 7. So this would be the solution of this equation. So here, two examples in which we need addition or subtraction, adding number or subtract same number from both sides. Sometimes we need to multiply or divide. We can do that. We can multiply both sides by any number, same number, and divide by same number. But it has to be a non-zero number. We cannot divide or multiply both sides by zero because this will destroy everything. So here, for example, when we have 1 over 3, when we have 1 over 3 times x, what can we do? Uh, to get rid of this 1 over 3, we need the coefficient of x to be 1. I multiply by 3. I multiply both sides by 3, because when you multiply 3 times 1 over 3, 3 cancels with 3, and you get x equals 3 times 6, which is 18. So this is the solution of this equation. Sometimes the coefficient of x is not a fraction, it's a number. So in this case, I need to divide both sides by 5. When you divide by 5, 5 will be cancelled with 5, and I will have x equals 20 over 5, which is 4, and that's the answer or the solution of this equation. So how to solve? What are the steps to solve any linear equation? This is an example. If you have a fraction, if there are numbers in the denominator, you need to get rid of these numbers. So what to do? You need to multiply by the LCD, which is the least common denominator, the LCD. If the denominators like here 3 and 4 have no numbers in common, no common factors, so the LCD would be their product, their multiplication, 3 times 4. So 3 times 4 is 12, so that's the LCD. Now what should you do? You multiply both sides of the equation by the LCD, which is 12. Now if you multiply by 12, you need to get rid of the parentheses now, remove all parentheses. So 12 divided by 4 is 3 times 3, it's 9. So I have 9x plus 12 times 3, 36. In the other side, 12 divided by 3 is just 4. So I have 4 times x minus 4 times 1. Now, what should I do? We leave the variable in one side, in the left-hand side usually, and the numbers to the other side. So I need 4x here to be removed to the other side. What should I do? I subtract minus 4x from both sides. When you subtract minus 4x, these two will be cancelled, and I'll have negative 4 in the right-hand side. In the left-hand side, I will have 9x minus 4x, 5x plus 36. Now I need to get rid of the 36. So I subtract 36 from both sides. These will be cancelled, and I will have 5x equals negative 4 minus 36, negative 40. Now I need to get rid of the coefficient. I need it to be 1. So I divide by 5. 5 cancels with 5, and we will have x equals negative 8. That's the solution of this equation. Finally, you need to check your solution. Check that you did not do any mistake here. Put negative 8 in the original equation. Replace x by negative 8 and check whether the left-hand side equals to the right-hand side or not. If it doesn't equal, it means you made a mistake here. So you go back and check your steps. Let us solve some exercises, some examples. Solve for z. We have a fraction. We have 3 in the denominator. So I will multiply both sides by 3. 3 will be cancelled with 3, and I will have 2z equals negative 18. And then I need to divide both sides by 2. Then z would be negative 18 over 2, which is negative 9. Notice that you can solve this equation by multiplying both sides by 3 over 2, because I have 2 over 3 here, 2 over 3z. So if you multiply both sides by 3 over 2, then 3 cancels with 3, 2 cancels with 2, and I have z immediately. And here 2 with negative 6, this is negative 3, and 3 times negative 3 is negative 9, and you will get the same answer. Now, how to solve this equation? I have two denominators, 2 and 3. No common factors between 2 and 3. So the LCD is 2 times 3, which is 6. So I need to multiply both sides by 6. So this is the left-hand side, and the right-hand side. All the terms in the right-hand side should be multiplied by 6. Now 6 cancels with 2 and you have 3. 3 times 3 is 9x. 3 times 1 is 3. Now here 6 divided by 3 is 2 times x to x, and minus 3 times 6 minus 18. Now I subtract 2x from both sides, so I will have 9x minus 2x, which is 7x plus 3 equals negative 18. I subtracted 2x from both sides, and now I subtract 3 from both sides, so I will have 7x equals negative 18 minus 3, negative 21. I divide both sides by 7, so x would be negative 21 divided by 7, negative 3, and that's the solution. And you can go back to the equation and check that if you replace x by negative 3, you will have a true statement. This is an application using data from 1980 and projected to 2050. The number of Hispanics in the US civilian non-institutional population can be approximated by this. So the population of the Hispanics in the US can be approximated by this equation. So he means that the population is denoted here by Y. So the variable Y represents the population of Hispanics. What about X? X, where X is the number of years after 1980. So this is the definition of X. So usually, or he must in the question, if he gives an equation, he has to define the variables for me. So X here is like this, and Y is the population. So I know each one of them. Now, what is the question? Usually, he will give me a value of one of the variables and ask for the other variable. So he says, according to this equation, in what year? In what year? So he is asking about X, because X is the number of years. Will the Hispanic population equal to this? So Y is equal to this, because the Hispanic population is Y. Notice here, he said Y million. So Y 36.74 million. So I replace Y by 36.74 and write the equation, and then I solve the equation for x to find the number of years. To solve the equation for x, I will subtract 6.084 from both sides. So I will subtract 36.74 minus 6.084 from both sides. Let me use the calculator. 36.74 minus 6.084, that's 30.656 equals 0.876x. And now I need to divide both sides by 0.876 to leave x alone, this time in the right hand side. So divided by 0.876, the answer is 34.6 0.995 something. So I can say that X is approximately 35 years. Okay, so what is the answer to the question? The question says, in what year? Oh, in what year? So what is X? X, the number of years after 1980. Okay, so I add 1980 plus 35. I I reach 2015. So in 2015, the population of the Hispanic would be equal to 36.74 million. Fractional equations when we have variable in the denominator. Okay, so like this, you have x in the denominator. If you have a number in the denominator, it's not fractional equation. If you have a variable, it's a fractional. What to do to solve it? First, we need to multiply by the LCD, the denominator. But we have to notice here that we are multiplying by a variable, both sides by a variable. And this variable could be 0. So there is a problem here. We have to, so what to do? We have to check our answer at the end, our solution. After you solve the equation, you must check your solution in the original equation. You must check it this time, because sometimes the solution, if the solution makes the denominator 0, for example, of the original equation, if the solution makes the denominator 0 in the original equation, then it cannot be a solution to the original equation. It would be a solution for after we removed the denominators, but for the original equation it is not a solution. So for example, let us solve this equation for x. And this is an important example because it needs concentration. I have x plus 5, one of the denominators, and the other denominator is 2x plus 10. If you look carefully, 2x plus 5 and 2x plus 10, you will notice that if you take 2 as a common factor here, or if you multiply this by 2, you get 2x plus 10. So in fact, 2x plus 10 is 2 times x plus 5. So there is something in common between these two, which is x plus 5. So the LCD here is not going to be their multiplication. If you multiply them, it would be an ugly situation and you will not be able to find the solution easily. So what is the LCD? It is in fact 2 times x plus 5, because x plus 5 is here and here, so I take it once, and the 2 is here, so I take it. So that's the LCD. So the LCD is 2 times x plus 5 or 2x plus 10. You can write it like this or like this. So I will multiply both sides by the LCD. I will write it 2x plus 10 in this side to see that they cancel with each other immediately. The right hand side has two terms. Both should be multiplied by 2 times x plus 5 or 2x plus 10. Okay, good. So I will have 3x equals, this times 1 would be 2x plus 10 plus. Now if you multiply this times this, x plus 5 cancels with x plus 5, and I will have 2 times 1, which is 2. So 3x, now I need to get rid of the 2x, so I will subtract 2x from both sides. 3x minus 2x would be x, and it would be cancelled from here, and 10 plus 2 is 12, and that's the solution. And you need to check your solution in this case because there is a variable in the denominator. So 3 times 12 over 2 times 12 plus 10 equals 1 plus. Notice that 12 does not make the denominator 0, so we have no problems here. If you check, you will find that both are equal to, this side is equal to 18 over 17, and also this side, if you use the calculator, it is 18 over 17. So x equals to 12 is the correct solution. Here, this is an easy question because the LCD is just x minus 3. I mean the LCD here is easy, okay? Because uh, we have x minus 3 in here and here, and it's the only denominator. So we multiply both sides by x minus 3. It would be cancelled here, but in the other side, you have to be careful because you have two terms, okay? Two terms. So you will have, or we will have, 2x minus 1 equals 4 times x minus 3. You write it like this. You have to put parentheses because you have two terms here. So 4 times x minus 3 is 4x minus 12. Then plus, if you multiply x minus 3 times the fraction, x minus 3 cancels with x minus 3 and you will have only 5. Now to get rid of the 4x, I subtract 4x from both sides. 2x minus 4x would be negative 2x. And here I will have negative 12 plus 5, that's negative 7. Then add 1 to both sides to get negative 7 plus 1 is negative 6. And now divide by negative 2, so x is negative 6 over negative 2, that's 3. So the solution of this equation is 3. But is 3 a solution of the original equation? And the answer is no, because it makes the denominator in the original equation 0. So what is the solution set of the original equation? It is phi, or the empty set, because x cannot be 3 in the original equation. But the solution of this equation is 3, but we don't need the solution of this equation. I need the solution of the original equation because this was the question. So the solution set is phi. You need to solve this one. Check that you can do it, please. It's easy. Let me help you with this one. I have two numbers, 6 and 9. How to find the LCD? Well, 6 is 3 times 2 if you factor, and 9 is 3 square. 3 times 2, 3 times 3, which is 3 square. Now, how to find the LCD? To find the LCD, you take everything, okay? The highest power of all the prime factors. So there is a 2 here, there is no 2 here, so I take it. While there is a 3 here and 3 square here. Okay, so 3 in common, but there is another 3 here, so I take 3 to the power 2. Okay, so 2 times 9 is 18. So 18 is the LCD. If you think to take 6 times 9, 54, it will be uh, more difficult because you will need to simplify more because you are multiplying by 54 instead of 18. 18 is less than 54, so it would be easier to deal with. So 18 times 5x minus 3 over 6 minus x. Pay attention because I have two terms in the left hand side and I have two terms in the right hand side. So here you need to do it carefully because you may do mistakes. 18 divided by 6 is 3. 3 times 5 is 15. So I have 15 times x minus 3. And then minus 18x equals 18 times 1 is 18 minus 18 divided by 9 is 2, so I have 2x. And all the denominators disappeared, okay, because we multiplied by the LCD. Okay, continue. Remove the parentheses. 15x minus 45 minus 18x equals 18 minus 2x. 15x minus 18x is negative 3x minus 45 equals 18 minus 2x. I want to get rid of this one, so I will add 2x to both sides. Then you will have negative 3x plus 2x That's negative x minus 45 equals 18. And now negative x would be equal to adding 45 to both sides and now dividing by minus 1 or multiplying by minus 1, you will get x equals negative 63. That's the solution, and you can check it in the original equation and make sure that both sides will be equal to each other if you replace x by negative 63. Let us solve this equation also. Notice here that x minus 2 and 3x minus 6 is just 3 times x minus 2. So this is similar to the one we just did here, to this one. X plus 5 and 2x plus 10. This is similar. X plus x minus 2 and 3x minus 2. So I will leave it for you. You need to multiply 3x minus 2. That would be the LCD, okay, times x over 3x minus 6, which is 3 times x minus 2. So these two would be cancelled. And then the 3 times x minus 2, you need to multiply by the two terms in the right hand side. Please continue the question and find the solution and make sure the answer is not 2. If the answer is not 2, then we don't accept the answer and it would be 5. Linear equations in two variables. Well, here I have two variables, 4 and y. So usually he asks you to solve this equation for one of the variables. So to solve this equation for y, I need to leave y alone in the left-hand side. So I need to get rid of the 4x. So I will subtract 4x from both sides. Then I need the coefficient of y to be 1. So I will divide by 3. So the answer would be 12 minus 4x over 3. Okay? Or you can write it 4 minus 4 over 3x. That's the solution. Suppose that the relationship between a firm's profit P, so what is P? Is the profit. You have to understand in applications, each variable represents what? And the number of items X. Okay, so what is X? Number of items sold. So X number of items sold. P profit can be described by this equation. This is a relation between X and P. The question, how many units must be produced and sold? So how many units sold? He is asking about X. For the firm to make a profit of 150 profit, so he is giving P. P is 150. So I go to the equation, write it again, and replace P by 150 and solve the equation for X and find the value of X. So 5x would be, I will add 4 times 150. 4 times 150 is just 600. So I will add 600 to both sides. So 600 plus 1200 is 1800. And then I will divide by 5. And when you divide 1800 by 5, you get 360. So that's the answer. The number of units must be produced and sold is 360 units. B, solve this equation for P in terms of X. Solve it for P, so I need P to be alone in the left-hand side. So I will subtract negative 5x or 5x. I will subtract 5x from both sides. So I will have in the right-hand side 1200 minus 5x. And then I will divide by negative 4. So P is 1200 minus 5x over negative 4. I can leave it like this, or I can write it this over this minus this over this. Find the profit when 2,400 units are sold. Find the profit. He is asking about P. When 240 units, so this is X. So X is 240 units. Okay, I have this equation. So P would be equal to 1,200 minus 5 times 2,240, the number of units, over negative 4. I can use the calculator and find 1,200 minus 5 times 240. The answer is 0. Okay, the answer is 0 in the numerator. So it's 0 over negative 4, so 0. What does it mean the profit is 0? If the profit is 0, it means this is the point of the break even. Okay, break even. uh, this is the point in which uh, the cost equals the revenue. The cost equals the revenue. When the cost equals the revenue, the profit would be 0. A last point in this section, the linear inequalities. An inequality is a statement in which you have greater than or less than. Quantity is greater than or less than another quantity. Like here, we have 3x minus 2 greater than 2x plus 1. Linear inequalities, first degree, means the power of x would be always 1, would be 1. Okay. Now, uh, if if the number satisfies the inequality, it would be a solution. For example, if you replace 4 here, it becomes true, so it's the solution. While if you replace x here by 2, it will not become true, so 2 is not a solution. So some numbers would be solutions, some numbers wouldn't be solutions of the inequality. Two inequalities are equivalent if they have the same solution set. Similarly, like the equation. What to do? What are the properties to use to solve inequalities? Solving inequalities means finding their solution set. Substitution property, same. I can 5x minus 4x, that's the left hand side. I can simplify and write it x. So this is called substitution property. X less than 6, x is less than 6, that's the solution set. So solution set x less than 6. If you want to write it in interval notation, so x less than 6 means x is to the left of 6. And this is the number line from negative infinity to infinity. So the solution would be x belongs to from negative infinity to 6 open, because there is no equality sign here. X is just less, not less than or equal. So that's the answer, from negative infinity to 6 in interval notation. You can add the same number to both sides, similar to the equation. For example, usually I need also to leave the variable in the left hand side and the numbers to the right hand side. So I have negative 4 here. To get rid of it, I add 4 to both sides, then they cancel, and I have 2x greater than x plus 10. Now I need to get rid of this x, so I subtract x from both sides, and x minus x would be 0, and 2x minus x would be x, so x is greater than 10. In interval notation, this is 10, and x is greater than 10, so it's to the right, and it goes to infinity, so the answer here is from 10 to infinity. That's the interval. Uh, can I multiply both sides by any number? The answer is no. If you, I can multiply, but I need to make sure of something. If you multiply by a positive number, you don't have any problem. So for example, here, x over 2, I need to get rid of this 2, so I will multiply by 2. 2 cancels with 2, x greater than 16, that's excellent. Here I can divide by 3 or multiply by 1 over 3. 3 cancels with 3, and x is less than 2. That's no problem. But if you are going to divide or multiply by a negative number, then you have to reverse the direction of the inequality symbol. if it is less than and you are multiplying by -1, you have to make it greater than. Okay, so negative x. If you multiply by -1, it would be x, and less than would be greater than, and 6 would be -6. So you have to pay attention to this. Here, -3x, we divide by -3, or we multiply by -1/3. So we divide it by a negative number, so we change greater than, we make it less than, and x would be less than 9. Let us solve this inequality. I have to get rid of the 3, so I will multiply both sides of 3. 3 is positive, so nothing would happen. 3 times 2 is 6. And if you multiply this side by 3, it would be cancelled with the 3 in the denominator, and I will have x minus 3. Now expand or remove parentheses. So 6x minus 24 is less than x minus 3. Now I need this x to go to the left hand side. So I subtract x from both sides. So 6x minus x would be 5x, and x minus x would be 0, and I will have -3. Now I want to get rid of the -24, so I add 24 to both sides. So it would be 5x less than 3, -3 plus 24, that's 21. Okay, -3 plus 24 is 21. Now divide by 5, so x is less than 21/5. 5 is positive, so there is no problem. So that's the answer. If you want to write it in interval notation, 21/5 less than, so the solution is x belongs to from -infinity to 21/5 open. That's the answer of the. So you can check your answer. You can replace x by any number here. For example, the 0, because 0 here. If you put x 0, you have here -8 and here -1. -8 is less than -1. That's correct. If you choose a number greater than 21/5, say 10, for example, if you put it here, you will find it not correct. By this, you can check your answer. Solve the inequality and graph the solution. It is easy. I add 2 to both sides, and then I divide by 3. Graphing means this is a 3 less than, so this side. That's graphing up to -infinity. So what is the solution? From -infinity to 3, and this time I close it because there is equality. Okay, checkpoint, please do this one, and also try to do this one. Okay, I will do the last one. This would be the last example. I have -3y and 4y here. I want to get rid of the 4y in the right hand side, so I will subtract 4y from both sides. Then these two will be cancelled, and I will have 4 minus 7y greater than or equal to 5. Now I want to subtract 4 to get rid of the 4 here. If I have -7y greater than or equal 5 minus 4, which is 1. Now I need to divide by -7, but -7 is negative number. So when I divide by -7, I change greater than to less than. So it would be y less than or equal to 1 over -7 or -1 over 7. So this is -1 over 7, and it is less than, so it goes to -infinity. So the interval notation is from -infinity to -1 over 7, closed because there is an equation here, equality sign. That's the answer of this question. Thank you very much, and see you in another video.